Welcome back to CSG 351 Chemical Process Principles, Module 4.1. In fact, Module 4 is the last module for the class. So we're going to be looking at Module 4.1 and Module 4.2. Both of them are separation processes. We've divided the two of them into separation processes 1 and the other module will be separation processes 2. Today is 17th September and it's Sunday. I wish you happy Sunday. Now for module 4.1, we're going to be looking at characteristics of separation operations, use of mass separating agents, common separation processes, a list of common separation processes, and we conclude. Separation processes, characteristics of separation operations. Separation processes are widely used in chemical manufacturing operations. The separation occurs through the transfer of materials from one homogeneous phase to another. The driving force is concentration, vapor pressure, or solubility gradient. Through mass transfer processes, the chemical components are selectively separated. For separation to have occurred, the phase must differ in composition. That's what we mean is that the initial phase we have and the final phase where we have done the separation must differ in composition of course, the components or species we have separated. Examples include distillation, crystallization, adsorption, absorption, extraction, even dehumidification, fractional distillation, and so on. Now let's just explain distillation. You know what distillation is? For instance, if you have a mixture of salt and water, now while you look at that mixture, you will not be seeing the salt, but the salt is already dissolved in the water. If you heat that water in an open vessel and the water starts boiling, there will be evaporation and the water will evaporate. The moment the water has finished evaporating, the salt will be left behind. That's very simple distillation. We can also have fractional distillation, which is a basic principle behind fractionation, which is used in petroleum refining. As you distill, you collect the components at different temperatures at their different boiling points. And we'll be able, by then, we'll be able to collect all the fractions making up the initial feed, which means we have separated all the components. The separation is caused by addition of a separating agent, so we can use a separating agent. Put the separating agent that collects or absorbs the particular material we want, a kind of carrier agent. It can be a mass separating agent. It can also be energy separating agent. Mass separating agent can be used. Now that mass, you can see the diagram there. Look at the feed stream is going into the separation device, and the separating agent that is used is added, and this separating agent will now cause for us to have two streams, product 1 and product 2. So like I said, it can be an energy separating agent, it can be a mass separating agent. For example, is distillation, in which separation is achieved by heat transfer. Like I said, when you heat, there will be a transfer, as the molecules of the water evaporate. The potential that exists is governed by equilibrium thermodynamics, which depends on interface mass transfer. If the two phases are intimately mixed, the rate of mass transfer is enhanced. You can see that. Then after sufficient phase contact, we can now separate the two. It can be by gravity, it can be by mechanical separation, or any other means. For instance, a very simple experiment I'm sure you people must have done in 200 level, when you use separating funnel. You have a mixture, you now add an organic phase. Now there will be a separation between the aqueous phase and organic phase. And the substance in question will be distributed. So which means you can do 2, 3, 4 times. And if it is in a continuous process, that stream can pass through, as we're going to see later, through 1, 2, or even 3 separating devices. So at the end of the day, the separation process will be achieved fully. Now, common separation processes. A list of the commonly used continuous separation methods is shown in the table below. We'll look at that table, the next slide. The most widely used industrial separation method is distillation, which utilizes difference in volatility or boiling point of different components in a mixture. So distillation, when you have different components in a mixture with different boiling points, it's easy for us to maintain at a particular boiling point for one component, and it is only that component that will be distilled off and collected. Now when you increase the boiling point again to the next component, that other component will start boiling and will distill. For instance, if you have a mixture of ethanol and water, ethanol boils at 78 degrees C, whereas water boils at 100 degrees C. So if you maintain the temperature at 78 degrees C, the water cannot boil and cannot go off as water vapor. It is only ethanol that will boil and be distilled off. Now you'll be seeing the distillate. As soon as the ethanol is finished, you will no longer see any distillation. And then if you increase the temperature to 100, water molecules will start boiling and will also start distilling. When the distillation is carried out in a column, containing a series of trays wherein a proportion of the overhead vapors is condensed and returned to the top of the column as reflux, the operation becomes fractional distillation, which I have explained. When volatility differences between species to be separated are so small as to require a very large number of trays in a distillation operation, extractive distillation may be considered. Another type of distillation which utilizes mass separating agent is azeotropic distillation, wherein the solvent becomes the most volatile components of the mixture. Remember your azeotropic mixture, constant boiling mixture, which eventually can use that to do our separation by using a mass separating agent. When the mixture to be separated includes species that have wildly different volatilities, then we can employ flash vaporization or partial condensation. Where the vapor from a liquid mixture or solution contains only one component, the process is described as evaporation. Like I said, when you are doing distillation and you are evaporating just the components you don't need, for instance, like an example I gave in terms of salt and water, we're not interested in the water, we're interested in the salt, so we can evaporate the water. So we're not interested in that. We have also described here humidification, also in dehumidification, which is opposite of humidification. We also have absorption process. We also have adsorption process. And in absorption process, soluble vapor is absorbed from its mixture with an inert gas by a non-volatile liquid, in which the solid gas is more or less soluble. Also, as in dehumidification, the transfer of solute is from gas to liquid in absorption. When solute is transferred from liquid to gas, the process is stripping or desorption. We also have liquid-liquid extraction. We have solid-liquid extraction, which is called leaching. These are different types of separation processes. Now, this is a list of common separation processes. You can see we have so many of them. The unit operation, you can have distillation, extractive and azeotropic distillation, flash vaporization, evaporation, stripping, extraction, and so on. You can see the separating agent that is used. Look at the products, basis for separation, and examples of each of these processes in the industry. Now, you see, we have looked at module 4.1, separation processes, characteristics of separation processes, common separation processes. And I hope to see you in the final module, that is module 4.2, shortly in the next class. And I hope you enjoyed the lecture. Thank you very much, and God bless you.